Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm going to talk about how to find sine lengths using the sine rule, and we do use sine rule if we have or cosine rule, but for this video just sine rule when we do have non-right angle triangles. If you do have right angle triangles, please use a Pythagoras because it's easier. So in non-right angle triangles, the corners of the triangle, like this one here, corners of the triangles are labeled with capital letters. So A, B, and C. So we have here angles as well. So we say angle at C, angle at B, and angle at A. And corners or vertices. I'm just going to write here corners. Okay, corners or vertices. So, and the corresponding sides across the angles labeled with small letter A across angle A. It's small letter A, and then across C, small C across B is small b. So pretty much the rule, sine rule is A over sin or sine of the corresponding angle is equal to B sin of B and is equal to C over sin of C. So the ratio between side A and corresponding angle sin A should be equal to the ratio between side B and corresponding angle B, and this should be equal to C and ratio of between C and corresponding angle sin of C. So this can be written in different way as well. So it can be written as sin A over A equal to sin B over B, and sin C or sine over C. So either, so you can choose either formula, so that should be fine. But please note that at the time, so at one time, or we should only use two of these formulas. For example, you can either choose, to use those two, like this one here, in order to find unknown sides or angle. In this video is just length. So, or you can choose those two in order to find unknown length. So, or you can choose this one and this one. So, and in order to find unknown length. So, I'm hoping that you're okay with that. So, only two formulas at the time. Now, let's go with examples. So, let's have a look. What do I have here? Okay, so example. So I'm just going to put here example one. Example one. So if I have, let me have a look. Okay, this is triangle. Triangle. So we have 23 centimeters, x centimeters, unknown side. So this angle is 37 degrees and 48 degrees. So as we have already seen that sine rule is side and corresponding opposite angle, sin of opposite angle, side, and corresponding opposite sin of that angle. So we're just gonna have a look what has been given here. So I'm gonna use this. So I have angle here 37. So and opposite this angle is 23. So it's like I'm gonna put like they belong together. And we have angle here 48 and opposite is x. So let me choose different color. So, and that's like, they go together. Now, all we have to do is just to be careful what we're going to use in numerator and what will be written in denominator. So if we start with, let's say 23, so if we start with 23, so 23 is over sine of 37. So this one here, 23, okay, it's across 37. So equal to, now in numerator, as we have started here with the side length, in numerator here we have to have the length of the other side. So in this case, that other length is x, so we're just going to write x here over sine of 48. Now all we have to do is just solve for x, and what I like to do or use is cross multiplication. So pretty much I cross multiply, so like that. So it's gonna give me x times, let me use this color, of like x times sine of 37 is equal to 23 sine of 48. Now we do have x times sine 37. We only need x. So what we're gonna do, we're gonna divide both sides by sine 37. And I have mentioned this before, so why we're dividing by the same number here? Because we want 1x, only one, not sine 37 next to it. And this, when we cancel out, is going to give us 1. So, and remember, whatever you do on one side, you have to do the other. So sine 37, and this is going to give us x equal to, okay, let me have a look, is equal to approximately 28.40 centimeters. So this is the first example. Let's go with another one, but before I move on to the other example, please note that this sine here and sine there can't be cancelled out. I have seen sometimes students do that. Sine and sine doesn't cancel out. You only cancel out if you have the same sine of same angle over sine of, you know, the other angle. Okay, let's go with another example. So the next one that I have ready here is pretty much, let me just sketch the graph, this one here. So what do I have? 108 is this angle. So this one is 31, side given 9 meters, x meters, and I think that's it, isn't it? Okay, so now using the rule, so I'm just going to write here a over sine A equal B over sine B equals C over sine C. So we do know we're looking for, you know, corresponding sides and angles, so as we have seen before. So let's use yellow. So I have here x and beautiful, this angle here, okay, so that goes together, beautiful. And now I have one angle given, and I don't have the side opposite given, I don't have the side given, and I have side given, but I don't have angle given. So let's see, what can we do? Okay, so now it would be really helpful to, if we do know, and we should know, that sum of all angles in the triangle, so sum of all angles in triangle is equal to 180 degrees. So, which means 180 is equal to 108 plus 31 and plus something that we don't know. So, and let's say this one, what angle? So let's call it theta or something. We can call it anything we want. So theta, so and plus theta. So 180 is equal 180, 18 and 31 is 138 degrees plus theta. And now we just need theta by itself. So it's take away one. Is that correct? 139. Okay, let's change that. So it is this one here, 139. So it's 139. And I'll take away 139 because you just want theta on one side. Whatever you do on one side, you do it to the other side as well. So it's take away 139. And this is gone. So theta, or our angle, is equal to 41 degrees. Now, this angle here is calculated. So what I'm going to do, I'm going to get rid of this. Yep. Okay. And instead, I'm going to write in red 41. So 41, which is calculated here. So like this, just there. Now, we do have two sides given and an angle, so which is beautiful. So let's do it. How are we going to do this? We can go now 9 over sine of 41 is equal to x over sine of 31. Please note how I have sides, both sides in numerator and both angles in denominator. You can go another way around, but you just need to be consistent. If you have sides in numerator, then it has to be in the first formula and the second as well. So let's do a little bit of calculation now. Cross multiplication again. Cross multiplication, just like this. So it's going to give us x times sine 41 is equal to 9 times sine 31. And then we want x by itself. Again, divide by sine 41, both sides, sine 41. And again, please note that this sine here and this one there, they can't be cancelled out because they belong together. Sine of an angle, sine of an angle, and they have different values. But we can cross out this because that would give us 1. And then from here, x should be equal to approximately, use your calculator and check if my calculation is correct as well, 7.07 meters. So that would be the length of the unknown side. Okay, so now let's move to next question, which is a little bit longer. Not too hard, but it just takes time and a few more steps. So if you do need to grab a drink or a snack or something like that, please pause and I will be waiting for you on the next slide. Okay, let's have fun with this one. So again, using the same rule, which I just write here. So label all sides, and pretty much the question is asking you to find the x in this form, a plus b times square root of 2, where a and b is, let me just say, nice, you can actually read that. So a and b are in Q. So, and if you do need to remind yourself what is the set Q, so it's pretty much, the set of rational numbers. And what are the rational numbers? Are the numbers that can be written as a fraction. So, sorry. So let's have a look. So again, I'm just going to go with using yellow. So, and go, okay, so I have opposite sides and angle, opposite sides and angle, and let's start. Okay, sine of 30 over x plus 3 equal to sin of 45 over 2x take away 5. So pretty much again, we're just going to do similar things that we have done before. So cross multiplication, just like that, and again cross multiplication. So this is going to give us what? Okay, x plus 3 times sin of 45 is equal to 2x take away 5. Please note I have brackets because I have more than one term that it will multiply sin of 30. Now before I expand, so what I'm going to do, because I have here sort of nice answers for sin 45, and if you use your calculator, so sin of 45, I'm using unit circle here because that's what I have next to me. So sine of 45 is square root of 2 over 2 equal to 2x take away 5, and sine of 30 is equal to half. Now, we do have fractions here, so I always tell my students, get rid of the fractions. I like getting rid of the fractions first so that, it just looks easier and more simple. So in order to do that, I'm going to multiply everything by 2. And then I'm just going to have here one line like here, because we're going to continue working on this question on the second half of the page. So multiplying everything by 2. By doing that, so it's pretty much like this. So multiplying everything by 2, everything by 2. So that's what it means. So then I don't need that. What is happening now is pretty much 2 and 2 gonna cancel out. So and 2 and 2 will cancel out. So we will be left with x plus 3 times square root of 2 equal to 2x take away 5. So beautiful, doesn't look bad. So now the next thing we're gonna do, expand the left hand side. So it is, we can divide by square root of, what we can do, divide by square root of 2 both sides, or it depends on what you prefer. So what I'm gonna do, I will expand, so x times square root of 2, then 3 times square root of 2. So, and that's gonna give me it will give me x square root of 2 plus 3 square root of 2, yeah, is that correct? Yeah, equal to 2x take away 5. Now one more line here. So what I will do, I would collect all x's on one side. Pretty much it means I'm gonna move this to this side. When I move it, it's gonna change the sign. So when I say again moving, pretty much this is what I'm doing. Take away 2x, and then on this side, take away 2x. So we're gonna end up here with what? X square root of 2 take away 2x plus 3 square root of 2 is equal to negative 5. And now same thing is gonna happen to this beauty here. This one here will be moved to the other side using the same operation. Take away take away 3 square root of 2 on this side, and same on the other side as well. So let's have a look what we have now. So rewrite all this and have, okay, x square root of 2 take away 2x is equal to, which one do I want to write first? Okay, negative 5 take away 3 square root of 2. So we have something common, x is common, so take x in front of the brackets. So x left with this and is equal to all this. So I'm not gonna say all these numbers, so you can just follow that. Yeah, I told you it's gonna be a little bit long, but The next thing to do is divide both sides by this expression, because we want to get rid of whatever is next to x. That's gone. Will give me x equal to -5, -3 times square root of 2, and over square root of 2, take away 2. Now, you may say, okay, I'm happy with this answer, and which is fine. So what you can do, plug into calculator, and it's gonna, give you a more simplified version. So, but the question said here to give answer in this form: x is equal to a plus b times square root of 2. And we don't have that. We have more than that. So what we're going to do, if you are familiar with conjugate pairs, so it is pretty much we are trying to get rid of denominator, like in this form when you have square root and stuff like that. So the conjugate pair would be to multiply both sides by this expression, which maybe you can recognize and see that is the difference of two squares. So what is going to happen when we do this, it's you're going to see in a second. Let me just rewrite multiply, whatever I have to do. 5 take away this part times this plus 2. And then what is happening in denominator, because it's the difference of two squares. So we have first term to the power of 2, take away 2 to the power of 2. So denominator is going to give us gone 2 take away 4. This is what is giving us. So, and the numerator, we would have to expand. So, using foil. So using foil. So -5 times square root of 2 is -5 square root of 2. -5 times plus 2 is -10. -3 square root of 2 times square root of 2. So that's gonna be -3 square root of 2 to the power of 2, because we do have that twice, like once here and once there. And the last one is -3 square root of 2 times 2, which is -6 square root of 2. Wow, that looks long, but that's fine. Okay, let's now try to simplify this. So what's happening? 2 take away 4 is -2. That's fine. So this 2 and this square root are gone. Now collect like terms. Negative, do I have, looking at collecting like terms. Okay, so we have here -10 and -3 times 2, which is -6. -10 and -6, it will be -16. And then -5 square root of 2 take away 6 square root of 2 is equal to 11 square root of 2. Now what we're gonna do, -2 is common for both terms, so it's pretty much common for this term, and it's common for that one. So which is, I can divide -16 by -2. It's going to give me 8, and I can divide -11 square root of 2 by -2, and it's going to give me +11/2 square root of 2. Now, hola, what actually we got here is a long journey. So our x is equal to 8 plus 11/2 square root of 2. And if you go back to the beginning of the question, it says to find the x in the form of a plus b times square root of 2. A and B are rational numbers, which means they can be written as a fractions, and this would be our answer. All I have to do now is just add my units here, centimeters, if you can see. Okay, hope this was enjoyable and you had fun finding unknown side in this question. Thank you for watching, and I'll see you soon. Bye.